Now we have Mr. Suvendra Kumar Senapati, Head Sales and Commercial Services, EMEA and IPAC Regions, L&T Digital Energy Solutions. Topic is going to be Innovations and Technology, the way forward to RE, Digitalization Accelerating Energy Transition. So with this, thank you so much, sir, for joining us. Everyone, can we give sir a huge round of applause, please?
First of all, good evening. I think I'll take you some of the, we're talking a lot of things in renewable, starting from the renewable technology, financing, skill, but I have not seen any of the forums digitalization is being discussed. So I thought, okay, we are doing a lot of things in digitalization, and I'll take some of the things in digitalization and how it is accelerating this energy transition. So I'll go through the various components, the technology available in the digitalization, and how we are getting into that. And some of the futuristic things I'll show, some of the screens I'll show how things are really being done. So this I belong to L&T Digital Energy Solutions, and that is a part. This is a part of Power Transmission and Distribution Independent Company. So this I'll just keep it like, okay, for the efficiency, for reliability, for the all those things, smarter operation, all these digital technologies are required. I'll not go into much into that. So if you'll see digital technologies in RE, there are a lot of components like RE integration. So the integration to the grid. So, and there is something called power plant controller there, PPC. So you see we have a software-defined solution for that. And we do power oscillation damping, spinning reserve, STATCOM integration, and all those things from that point of view. So coming to digital twin for asset performance or renewable performance or your renewable plant performance, we have there is a solution called asset performance or plant performance system. So it comes into play. Some of the plants, they require also a trading or settlement there from the plant side. Sometimes it happens in a load dispatch center. So that particular energy trading and forecasting solutions, that comes into play. So forecasting is an important aspect because today is not only day ahead forecasting, there's a cloud and you need to have those forecasting instantly 2-3 hours before so that your generation and grid is taken care. Net zero, we talk it E3MS, there is a solution, and it's all grid interactive net zero buildings or industries. Then comes the economy dispatch, where your battery energy control system comes into play for the renewable smoothing or energy time shift, those sort of, and grid stability, those sort of things is being taken care. Then it comes hybrid energy for the integration of DRs. You have a storage, you have a PV, you have a renewable, and you have also thermal or gas. So those things are being taken care here. Then you have a microgrid for carbon footprint reduction, or the industrial microgrid, or a commercial microgrid. So it is being done in that level. Then the sustainability in EV side, something called charge point management or site hybrid energy management system. So all these things are the components of the energy transition, basically digital components, and which is accelerating this transition. Then I'll just see what sort of things we are utilizing, what sort of technologies. If you'll see first, earlier the traditional thing is the PLC-based solutions, And today we are migrating to the software-defined solution. You take your software, put in a compatible industrial PC or a server, then you manage the whole ecosystem. So, and processing speed is very fast because the renewable generation happening in gigawatt scale in a single place. So you require a lot of faster processing and response time. For that reason, it is being done. So data learning with real-time solution for the DR management. This is what is being done. Then power system modeling with digital simulator and validation and integration, because first, to put that in the field, we need to have a study first. Then, based on the study, you simulate the system, validate it, and put it. So, so this is very important aspect, and we have our Opal RT and RTDS simulator to execute these functions, and various seasonal changes, various load changes, balancing, all these scenarios is being managed and monitored there. So I did mention that solar PPC, battery energy storage solutions, hybrid energy solutions, microgrid solutions, energy trading and forecasting. This is on meter data acquisition and plant settlement system, equipment efficiency that I explained for the grid interactive net zero buildings or industrial setups. Charge point management. So this is a beautiful thing, like you need to have a lot of network modeling studies. So we have PSSC and PSCAD things being done there. And a particular user-defined model for every controller is being done, because the applications and the parameters are different, and it varies from customer to customer, plant to plant. And I did mention that real-time simulation happens in Opal RT and RTDS simulator. And RTDS is more accurate than Opal RT. And based on the requirement, we need to test that. And grid integration balancing is a very important thing, because today a lot of renewable we are pushing to the grid. And so the grid stability, resilience is important. So for the study is important. And after study, you have to simulate, validate, then only you can deploy. So this is very important. So, and same thing, advanced grid services, power system requirements. So hardware in loop testing, those things is being done. Cybersecurity comes in the core of the whole thing. So it is OT cybersecurity. It applicable to all these components. So it is required for the whole of this particular integration requirements. So we have something called a Spark, L&T Spark platform. So if you see the blue color things, all 1, 2, 3, 4, 5, these are all our products, and all yellow color are the solutions. The renewable hybrid integrated solution, so basically it goes to the energy transition, solar, wind, battery, all those requirements. Utility merchant energy, basically today we have a digital substation or virtual substation, which reduces the your space, improves the response time. Those things go into that. And apart from that, all your distribution management, transmission management, those things goes into that. Transactive energy and asset sustainability, all the settlement, settling, accounting, those things goes there. And the sustainability or asset performance management, those things goes there. This is basically UME, Utility Merchant Energy Power Delivery Data Integration. All the AI, ML, all the data is coming, but how to analyze that, how to take an informed decision based on that, that comes there. The EV I mentioned, there is charge point management. Energy innovation and services, basically that is the grid integration, grid modeling, grid resilience, those services there. Network operation center, okay, that's not applicable in India. So multiple customers, multiple areas like EV, like renewable, you monitor from a single place. Cyber security, OT, it applicable for all these functions. So just I'll give a metadata acquisition, how things happen, generation happen, then data comes to the control center, then it gets validated with the LDC, then things are getting settled. Just I'll give some screenshots so that everybody is in consumption. These are the grid services and grid integration. We are doing a big job in NEOM where you have 2 gigawatt NEOM Saudi Arabia, 2 gigawatt solar, 1 gigawatt of wind, 400 megawatt by 400 megawatt hour of storage, and 200 have a grid connection. So those applications, it is like a sort of a macro grid. All those applications happen here. This is a microgrid and not connected to the EB, electricity board. It is from a factory in Chennai. So you have a storage, you have a solar, and also you have a BIPV, building integrated PV. So those things are there. And a small DG set for emergency purpose. And it comes to the net zero applications of energy efficiency and equipment. So this comes to the bit of analytics side. So today we have a generation, transmission, distribution, and trading. And individually they are being monitored. So today if you'll go to a control center, I don't have a line of sight, or their CEO or their, nobody has a line of sight what to do. So all these applications, key parameters, I'm taking a dashboard, what is happening in the generation side, what is transmission, what is distribution side. Then we can take a call. Okay, I require extra generation power, or I can do a power banking, or I can do some load shedding, or I can do purchase from the spot market. So those applications are being done with the advanced analytics. These are the, I mentioned you, power plant controller, which successfully gives command to the inverters and successfully delivers the power to the grid. And there is a active power, reactive power, those applications are here. And power quality management gives the data. Based on that, this power plant controller gives command to the inverters. So if any inverters is down, the other inverters take up, and this is a web-based application. Your SCADA is failed, then you can directly go to this application. From there, you can manage and control the whole solar plant. So that is a beautiful thing here. You need to really depend on the SCADA. Go directly, web application from a laptop or a PC, you can control the whole power plant if there is a failure of SCADA. These are the hybrid energy management system. Some of the customers we have deployed in India and the Middle East and the US also. So all the PV, storage, those things are there. This is a basically battery energy storage system, hybrid energy. These are one of the things we did in India, a digital substation, and we have done 5 different mix of merging unit and relay interoperability functions. That's the first time in the world it was done. Nowhere in the world now is being done. And on the top of that, we are also getting into a virtual substation where all the control functions are being done from the protection control functions is being done from the software. That is work in progress. So this is a beautiful thing, ESG. And we have something, ESG dashboarding. So all those parameters we are monitoring, and advising the customers what sort of actions they have to take, and over the years when they will be net zero. So those sort of things also being done. I'll go to some of the data. Data is available, but how will take the data, set the goal, then analyze, visualize, take action. So this about until unless you visualize, you measure, you analyze, then you cannot take control action. So that is important. Every time you have to monitor. So that helps us to improve our in the carbon management, carbon reduction. So some of the areas, some of the customers we are working in this area also, and definitely it is adding to the energy transition and carbon neutral management. Give us some of the slides. I will not going into detail because my aim is to show you what are the things we are doing and the futuristic thing which is helping for this energy transition. So for some of the projects we have done, like Saudi Arabia, few projects we have done, NTPC we have done few projects where our power plant gone into. Some of the EV customers like Blink in USA, we have deployed few of the things. And gigawatt scale solar, we are a single place, we have already done in Saudi Arabia. And across all these functions, the cyber security, the studies, the simulation, those things come into play. They're central to all the applications. These are some projects in EV and microgrid. So Amazon microgrid, we did the last right. Kanchipuram, my factory before that. So my campus in Chennai. USA, Blink, there some of the customer CPU charge point operator we have done. Then few of the renewable projects, already we are doing that. Some of the DMS projects we have taken, we are doing for the Mumbai based and Gujarat. Some of the transmission asset monitoring for power grid for the 400 substation we are upgrading. So 8 control centers across India and main backup at Manesar and Bangalore. So these are a few implementation of CMR solutions, the dashboarding. I'll show you quickly. So analytics, how the AI ML is helping for a predictive and prescriptive analytic solutions. So these are some of the futuristic labs where all these softwares are being tested and validated. Something in Chennai, something is a facility at Dallas, and something at FAT Center at Noida. This is for this balancing authority, the top left. So all this EV, the renewable, all these things is being done there in California. And this is the RTDS facility in Dallas. So all the testing validation is being done. So then your real time, your accuracy of the response time, those things being managed there. Okay. Thank you.